They're the initial situation. Then after collision, let M1 move with a velocity V1 and M2 with V2, and M3 what happened? Still it will be at rest, no? Apply as the elastic collision, any collision momentum is concerned. So therefore, what is the formula? M1 V0 equal to M1 V1 plus M2 V2. What is M1? 4 V0 is equal to, this is 4 V1. We don't know both M2 V2. We don't know. Call equation 1. Apply quotient of restitution formula. V2 minus V1 by V0. So V0 equal to V2 minus V1. Directly I'm writing it. Anything directed towards right is positive. So this is the equation 2. Oh, V0 minus V1. Let's solve this. So we'll get expression for the V1 and V2 in terms of M0. Because M0 is what, like M2 is what unknown, no? Just let's proceed here. Nothing to do that one. So if I solve it, so here should be, let me substitute V1 because V1, V2, two unknowns are there. Anybody? Equation V2 equal to
8 V0 by M2 plus 4, sir.
Let me keep. Now what will happen? This V2 will go and collide with M3, no? So the problem, I'll continue here. Oh. This will continue to move. Now 2 and 3 will collide after collision. Let me take this as V2 dash. Let it be V3. So then the formula will be M2 V2 should be equal to M2 V2 dash plus M3 V3. Applying quotient of restitution formula, V3 minus of V2 dash, or anything directed towards right, positive, by zero. So therefore this should be, and E is equal to 1. So what is V2 equal to? V3 minus V2 dash. M2 we don't know, we know M3. M3 is how much? 9, no? Let me substitute that 9 and solve it further. So M2 we don't know. V2 is how much? 8 V0 by M2 plus 4. Let me write that equation. M2 V2 dash plus, this will be 9 V3. So let me call this as equation 4. Okay, this is, so this is the, now what will happen? This is the equation 5. What is the condition given for us? We want M3 to move with maximum possible velocity after one collision. What should be the mass M2? M3 should move with maximum velocity. What I should do with this one here? So I should bring expression for V3 in terms of M2, then I'll differentiate. That's the only alternative available, no? Whenever maximum minimum comes, we take help of mathematics here. So from 4 and 5, I eliminate V2 dash. From 4 and 5, I'll eliminate V2 dash. Then I'll get expression for V3 only in terms of M2. Then I'll check for any condition for maximum minimum. So put solving 4 and 5. Anybody value V3 in terms of M2?
Sir, 8 V naught M2 by 4 plus M2.
I'm adding up this much. I solved it. It's there available now with me. 16 M2 V naught by 36 plus 13 M2 plus M2 square. Solving 4 and 5. Okay, this I should differentiate with respect to what? With respect to M2. Check once check it. If you're okay, then I'll proceed further with calculations.
Yes, sir, we'll get that only.
Yeah, this is equation 6. Now differentiate this. dV3 by dm2. And solve it and equate to 0. You'll get the value of m2. And that particular m2 is what that is being asked. Okay, try with the mathematics. You can take m2 common and eliminate m2 in the numerator. So I'll do one thing, one more step. 16 V naught 36 by m2 13 plus m2. I think this will be much easier for you to differentiate. Now differentiate this with respect to dv3 by dm2. 16 V naught take as it is. So this everything will be minus of 36 m2 plus 13 plus m2 whole square. There's a bracket, no? Then differentiation of that bracket will be minus 2 into 36 m2 m2 square plus 0 plus 1. So dv3 by dm2 should be equal to 0. The bracket should be equated to 0. So m square equal to 36. So m2 equal to 6 kg. So this is my answer. Then you substitute the value of m2 there. Then that v3 max you can determine. Okay, I think so. There's nothing big. Don't get scared with the conditions given. So suddenly, again, the everywhere. What is the basic idea? Conservation of linear momentum. You can see this. Everyone knows now, and how to apply quotient of restitution. That also everyone knows. Just carry on. So most of the one-dimensional collisions are just revolves around conservation of linear momentum, quotient of restitution. Two-dimensional collisions, little bit some impulse momentum equation have to be interpreted properly. Now you can ask questions, sir. Why you are not bothered about C frame? Tell me, like in C frame, to enter into C frame, what you should do? First, you should know velocity of object with respect to ground. No? Then you should know velocity of center of mass. Then you can interpret in C frame. We want to answer very quickly. So C frame problem, when you should do, when it's a conceptual thing comes, take help of C frame. One-dimensional collision, C frame not advisable. Because already unknown things are there. Velocity of colliding objects unknown. For C frame, to enter into C frame, what happens? First, you should know velocity of colliding objects in ground frame, velocity of center of mass. Once you know velocity of colliding objects in ground frame, problem is over. If they ask you anything conceptual, take help of C frame. Two-dimensional collision, C frame is very important. You try to solve this in C frame, it'll be very lengthy. You feel unnecessary what I'm doing. Please do experiment. It's not that teacher only tells, then you should accept here. You do experiment. Try to do same problem in C frame. You'll be in a big trouble. You feel like a lot of calculations why I brought this one. Unnecessary calculations we have introduced. So one-dimensional collision, only conceptual analysis, C frame is better. try to do problem in lab frame. We did everything in lab frame now. Okay, complete problem, I'm showing it. Okay, all of you. Harshavardhan, there is some limit for thinking. I'm not scolding you. I'm not scolding you. We don't know M2 itself, no? The velocity of M3 should be maximum. We want M3 to move with maximum possible velocity after one collision. What should be the value of M2? So can you just say that M2 equal to M3? Because sir, you only said equal to 1. Will this logic will work out here? Somebody has raised this simplified way of thinking. That's for elastic collision, for M3 to move with maximum velocity, if M2 equal to 9 kg, I think it's over the velocity of because all the velocity of 2 will be transferred to 3, but the 2 should acquire maximum velocity after collision with 1, no? Then only it can transfer that maximum velocity to 9 kg. So therefore, what happened for maximum possible velocity, what happened, we are searching value of M2. I think you should not stick on to the just formula or the information. So don't try to generalize everything. There's what the major problem in physics. Maximum students wants to generalize everything. So what all the velocity of M, because the M2 and M3 if masses are equal, then what all velocity of M2 will be transferred to the 9 kg M3. Okay, that is correct. But M2 should acquire that maximum velocity when it collides with M1. Why you're not going for that condition? So yeah, definitely the M2 is 6 kg. So the maximum possible velocity of this one. He didn't ask the maximum transfer of energy. He's just asking the M3 should move with maximum velocity. I think it's very important. Maximum transfer of energy is different and M3 should move with a maximum speed. It's a good question, but you should not generalize everything what all you learn. It's not possible in physics. We do get different situation to situation, you must interpret. Okay, completed this one. So I think now we have, okay, tomorrow I'll continue. Some good problems are there. Okay, tomorrow I'll continue remaining from here.
Sir,
Yeah.
sir, as you have said, transfer of energy and maximum possible velocity are different, right, sir?
No, yeah, that one.
Sir, here if the question is like transfer of energy, then what should we do, sir?
Then what will happen? The M2, what will happen? M2 should see the transfer of energy from M2 to M3 when it will be maximum, when elastic collision masses are equal.
Yes, sir.
Then so the M2 should be 9 kg. And again, M2 should acquire the maximum transfer of energy from M1, no? Because see, M1 is what giving energy to M2.
Yes, sir.
So then what happened? The M1 what happened should give maximum energy to M2. Then M2 what happened should give maximum energy to M3. Then again we have to search for maximum